Hello, this is the luckiest maths teacher in the world. Your life is about to change because we're going to learn about theoretical probability. Now you already know what probability is. Theoretical just relates to the word theory. So we're looking at what happens in theory. So today, as promised, we're going to go a step further. What we're going to do is actually assign to events numbers. We're going to give events numbers to indicate how likely they are to occur. So, as I said last time, whenever we're asked about the probability of something, the number that you give must always be between 0 and 1. Okay, luckily there's a very simple formula for how to calculate theoretical probability. So here's the formula, and you can take it down if you like. So it's saying that theoretical probability is just the number of ways an event can occur divided by the total number of possible outcomes. Easy as. So let's look at a few examples. So let's say I toss a coin and I want to find the probability that I get a heads. Now we usually write probability of an event as P and then the thing we're interested in brackets. So probability of heads I write just like this for shorthand. Don't worry, all mathematicians will know what you're saying. This is really easy. Probability of heads, we already know it. So why is it 0.5 or a half? Because on the coin there is one head, so the number of ways I can get a head is 1. But there are 2 possible outcomes, heads and tails. So that's why it's 1/2. Let's look at the probability. Let's say I roll a die and the probability I roll a 6 on a normal die. Okay, again, there is 1 6 on the die, but there are 6 numbers in total that I could get. I could get 1, 2, 3, 4, 5, or 6. So this relates to sample space. So probability I roll a 6 is just 1/6. What if I take the same die and I roll it? What's the probability I roll an even number? So remember, this symbol here means number, not hashtag. So the probability I roll an even number. So we're just using our formula. So how many ways can that occur? I could get a 2 on the die. I could get a 4 or a 6. So there are 3 ways that could occur. So 3 goes on top. Now the total number of outcomes is still 6. I could get 1, 2, 3, 4, 5, or 6. There are 6 possible outcomes. 3 of them are the favourable outcomes. 3 of them are even numbers in this case. So the probability is 3/6. Now it's important here, if you give your answer as a fraction, it should always be simplified. So 3/6 is the same as a half. So if you roll a die, there's a 50-50 chance that you'll get an even or an odd number. But please remember what I said in the last video. If I ask for the probability that you get an even number, you must give me a number between 0 and 1. You can't say 50-50, can't say even chance. You must give me the answer a half. Okay, that's clearly a number between 0 and 1. If I said, is it likely that I will get an even number? You can say it's a 50-50 chance, but if I say what is the probability, you must give me a number. Okay, let's look at a few more examples. So let's say now that I toss 2 coins and I want to find the probability that both are tails. So that's what this says here, probability I get 2 tails. So we can think back to last lesson and sample space. So I'm just going to quickly write down the sample space. So if I toss 2 coins, here are the possibilities. So I could get 2 heads, so head then head. I could get a head first go and a tail second go, or I could get the other way around. I could get a tail first, then a head, or I could get both tails, okay? These are the only possible outcomes, so there are 4 of them. So if we look at them, only one has 2 tails. So the probability that I get 2 tails if I toss 2 coins is 1, because there is 1 way that I can get 2 tails, over 4, because there are 4 possible outcomes. So notice here that if I wanted the probability that I get 1 tail, I could have this outcome, head then tails, or tails then heads. So the probability of getting 1 tail would be 2/4, which is a half. Okay, so let's just take a step back and think what we're actually looking at. So what we're looking at is what should happen. So in all of these examples, this is saying what we expect to occur. So let's look at this one here. So the probability of heads is a half. So what that means is that I expect that if I tossed a coin many, many times, I'd get half of them heads, half of them tails. That doesn't mean that it will happen. If I toss 10 coins, I could get 10 heads, or I could get, 8 heads, 2 tails. Theoretical probability is what should happen. So I expect that the proportion of times I get heads is a half. Similarly here, if I roll a die many, many times, there's no guarantee that I will get exactly 1/6 of them as a 6. I might get more 3s than 6s if I roll it many times. But what it says is that I expect that if I roll a die many, many times, 1/6 of those occasions I will roll a 6. On 1/6 of those occasions, I expect to roll, say, a 2. Here, when it says the probability of rolling an even number. So I expect that half the time I'll roll an even number, half the time that I roll an odd number again. Doesn't mean that will happen, that's just what should happen. Okay, I'm just going to do one more example with a probability spinner, and you'll have to get acquainted with these. So this here is a probability spinner. So I'm looking at the probability that if I spin that little arrow in the middle, that I'll land on a certain color. Okay, so let's say, look at this spinner and let's try and figure out what is the probability that I land on green. Okay, now this probably seems weird. How am I going to use this formula up here? How do I figure out the number of desired outcomes? What you can do is look at this and see that it appears to be divided into quarters. So 1/4 is red, 1/4 is green, and we can see that basically 2/4 of it, this quarter here and this quarter here, are blue. So the probability of green, we can now use that formula. One of the quarters is green, and there are 4 quarters in total. So the probability that this spinner will land on green is 1/4. Again, if I flick that arrow many, many times, I'll expect that it will land on green 1/4 of the times, even though that might not happen in reality. So then the probability of blue, for example, would be 2/4, because 2 of the quarters are blue, and of course we simplify our fraction. Now the probability of yellow, of course there is no yellow on this spinner, so any event that's impossible has probability 0. The probability that it lands on, say, blue, red, or green, so we can think about that. How many of these quarters are blue, red, or green? Well, there's 2 blue, 1 red, and 1 green. So 4 of those quarters are favourable outcomes. They are either blue, red, or green, and there are 4 in total. So the probability that it lands on blue, red, or green is 4/4, which is 1. That's a certain event. Okay, so if you use this formula here, you will be fine. Hope you've enjoyed this. Have a wonderful day. This is the luckiest maths teacher in the world.